Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the different types of definitions and terminologies in database management system. So different types of database definitions we are going to discuss. So in the database management system, the main thing is we need to know about what is meant by data actually. What is meant by data? So there are different types of data are there. So how the data is helpful and what is meant by the data, the data are related to the database and database software, who will manage this and where we can store and how we can retrieve the data. These are all we are going to see here. So first one, data. So what is meant by data actually? So data is nothing but it is a collection of raw bits or different facts, different numbers, different alphabets, all anything, collaborative of all the things is called as what? Data. So it may contains numbers, it may contains special characters, it may contains alphabets, it may contains upper letter, lower letters, anything. All these are nothing but what we can call it as data. So without data we cannot do anything. So without data we cannot analyze, we cannot process, we cannot organize, we cannot do anything. So what is meant by data? So it is nothing but what? Collection of all the different facts, raw bits, numbers, alphabets, anything. Collaborative of all the group of things is called as what? Data. From that database, so database where we need to keep the data in proper order. So we have the data but where we can arrange them, in proper order, where we can keep them in different organization way. So the place where we need to keep the data in proper order, so that means sequential order, non-sequential order, however we can store the data, we can keep the data in proper order. So that is nothing but what? Database. Database software. So who will manage this about all the database? So a software which is need for storing all the data in proper order. So to manage the data, to process the data, to organize the data, to do all these things, a software is required. A software is required. So that software is called as what? Database software. There are different types of database softwares are there. An example, MySQL, Oracle, DB2, MongoDB. These are all some database softwares who will manages the data to processing, to organizing, to managing all the things. So that is a database software. Data warehouse. So data warehouse is nothing but what? Is a place or location. It is a place or location to store all the different types of data. To place is a place or location to store all the different types of data. So different types of data are nothing but what? So images are one type of data. .txt files are one type of data. Dot video is one type of data. Audio is one type of data. Images are one type of data. PDFs are one type of data. So such a type of all the data. So such a type of all the data to be placed at particular place, to be placed or stored at particular place. So that is nothing but what? Data warehouse. It keeps all the different types of data. Data mining. It is a process of discovering the knowledge from the database. Discovering the knowledge from the database. So we already have the data, but what the data exact we want? What data exactly we want? So that is nothing but what? How we are going to process to find out the data is called as what? Data mining. So it's a process of discovering the knowledge from data or database. So that is nothing but what? Data mining. And information. Apart from this all, what is information? So it is nothing but exactly the meaningful of data. So data is nothing but what? All the different types of or collaborative of all the things. But from that all, we are going to have a meaningful way. We have a following meaningful way. So The meaningful data is nothing but what? Information. The, the data which is used as a information, that is called as what? Information. It is exactly the meaningful of data. So from this all, we can conclude that what is the data and information is same or not? Is the data and the information is same or not? So we can see. So data is nothing but what? Data is a raw, unorganized facts that need to be processed. So data is nothing but what? A raw, unorganized facts that need to be processed. So it can be simple and seemingly random and useless until it's organized. So before it is organized, it is not meaningless. It is not meaningful. So the data is organized, then it will becomes meaningful. So the data is nothing but what? The raw or unorganized facts that need to be processed. That need to be processed. So without processing, without organizing, the data cannot be in meaningful way. So that is all about to data. But in the information, when data is processed, organized, structured, and presented in given context, so as to make it useful, it is called as what? Information. So when the data becomes processed, organized, structured, and processed in a given context, so it has to make it is useful. So it is called as what? Information. It is called as what? Information. So before processing, before organizing, before structuring, before presenting, that is data. But when it comes to processed, when it comes to organized, when it comes to structured or presented, it becomes an information. It becomes an information. So see the example here. The data which we have, like 51007. This is not an order, not in proper meaningful order. So to make it as a meaningful order, we can convert into meaningful way. We can write it in like this also, and like this also, and like this directly also. So if we can make this into proper order or make this into proper structure like this in a given context, then it will become an information. So this is, we can say that, a date of your final exam or date of birth of yours, and this will be taken as a salary of your for monthly, or salary of average monthly, and this will be taken as a zip code or pin code of your state. Or so when the data is processed or organized or structured, that automatically will becomes into information. Automatically it will becomes into information. So the information can be useful to retrieve the data, but not the data can be useful to retrieve the information, right? So that is the way we can understand the difference between data and the information. So what is the data and what is meant by information? And without proper organized, proper structured, proper presented, the data cannot be used for meaningful. When it becomes proper organized, proper structured, proper processed, then it becomes useful way, then it becomes an information. So everyone can use the information to retrieve some data, but not they can use the data for the information retrieval. So from this, database is a collection of information that is organized in tables and stored on a computer system. So that is what we understand. So database where we can keep all the data. So we can keep the data in tables on computer system. This information can be updated. This information can be updated or modified. So data can be updated or modified if required, if it is required. And we can also say it's like a room in an office. It's like, take an example, it's look like a room in office which has a cover of files, which has a number of files. If we don't have a defined process, we will not know how to get the data from the room. So if the files are not organized in proper way, we cannot take that file as what we require. So if that all the files are organized in proper way, then we can easily take it and give it to someone. So that is the main thing of organization of the data. Database management system. So what is meant by it? So it is DBMS is a software for creating and managing data in the databases. So you can create the data by creating the databases, by creating the tables also, and also manage the data. If you want to insert, if you want to delete, if you want to update, you can do all that operations by managing the data in that system. So it provides users and programmers. It provides both users and programmers defined process for data retrieval. So DBMS uses different users and programmers. For what purpose? For the data retrieval purpose, for the management of the data purpose, for updation of the data purpose, and for the creation of the data purpose. So to do all these things, everyone, a person is required. So that person may be user or maybe the programmers. The person is maybe the user or maybe the programmers. From this data abstraction, the system hides certain details. System hides certain details of how the data are stored. So physically we can see the data in tables, but logically how it's stored and maintained is called as what? Data abstraction. So hiding the details of the data, how it is structured, how it is organized, is called as what? Data abstraction. So to hide that all the data, it follows three levels of abstraction. Three levels of abstraction. So that is three levels are nothing but what? View level, conceptual level, logical level of the data. View level schema is one level, conceptual level is one level, and logical level is also one level of schemas that are used to hide your details. And different types of database components are there. So database components, database structure components, or database architecture components. We can have different types of how it is going to be architectured in the database in real time. So how it is organized, how it architectured means the database architecture compresses of different types of components. One is what? A disk storage. So it specifies the storage of the data. It specifies storage of the data. So where it is stored actually. So that is what we understand from the disk storage. And storage manager who will manage the storage. Who will manage the storage? If any storage is not ready to occupy, then you need to allocate the space. So who will manage this all things? Means memory manager or storage manager manages all the memory allocation and deallocation of the database. Memory allocation and deallocation of the database. Query processor. Query processor. It processes all the queries that were executed on database. So query processor execute all the queries that we are writing on the keyboard, that we are writing on the screen through keyboard. All the queries were executed on database by this query processor. By this query processor. Next one, compiler and linker. Compiler and linker. It compiles and runs the queries in database. So whatever the query we are written on the screen, it will be compiled. It will be compiled and run the queries. It will be compiled and run the queries on by the linker. Query evaluation engine. So it processes the queries. It processes what? Queries and evaluated. So they can evaluate it whether the query is valid or invalid. So suppose if I write one query like a select star from table name. If I write this query, it is validated. It is validated because of the query syntax is correct. If I write select star from one table, if we are writing like this, it is not taken. It is not taken because it is not at all in syntax proper way. It is not at all in syntax proper way. So query evaluation engines checks whether the query is valid or not. Whether the query is valid or not. DDL interpreter. It processes all the DDL queries. It processes all the DDL queries. That is nothing but what? So create, rename, alter, drop, truncate, all these queries under DML queries, select, update, insert, delete, all these queries are executed. All these queries are processed by DDL interpreter. And application program object code. So it contains what? It contains all the instructional code. It contains what? All the instructional code that to execute on the database. That to execute on the database. To execute on the database, it having some instructional code. So that is about application program object code. So these are all different types of architectural components that are used to manage the database software. Manage the database software. So each and every one having its own importance. Each and every one having its own importance. To do this, to design the database, we can have different types of models. We can have different types of models, but among that all, the main important model is to entity relationship model. Entity relationship model. So, what is that model and how it is used to design the database model? So, ER model is based on the notation of real world entities and relationships among them. So it is nothing but what? It is a notation of real world entities, entities and relationships, entities and relationships among them. While formulating a real world scenario into the database model, the ER model creates an entity set. ER model creates an entity set, relationship set, and general attributes and constraint also. General attributes and constraints also. So ER model creates one entity set, creates relationship set, general attributes and constraints. These are all are created in the ER model. So from this, what is meant by entity, what is meant by relationship, what is meant by attribute, what is meant by constraint, we are going to discuss here. So an entity in an ER model is a real world entity, and it is having properties called an attributes. It is having a properties called attributes. So entity is nothing but a real world entity, real world object. It have the properties. So every attribute is defined. It's a set of values called domain. It's a set of values called domain. So how that attribute contains the values, and each and every set of values will be called as what? Domain. For example, for example, in a school database, a student is considered as an entity. So take an example, a student is considered as an entity, and the student has various attributes like name, age, class. So we can have name, age, and a class, or these are all the attributes. But this is the entity. So that is what we mentioned here. Entities are represented in what? Rectangle manner, and attributes are represented in what? Ellipse manner. So the entities, in between the entities, relationships exist. In between the entities, relationship is existed. So what is meant by relationship? So the logical association among entities is called as what? Relationship. So logical association in between those two entities. Here, these two, this is entity 1 and this is entity 2. In between these, a logical association. This logical association is called as what? Relationship. And this relationship will be indicated with the symbol of rhombus or diamond symbol. So relationships are mapped with entities in various ways. Relationships are mapped with entities in various ways. So mapping cardinalities define the number of association between two entities. So what are those two entities? So entity 1 and entity 2. And between those two, it having the number of associations. So it may be one to one to many to one, many to many. So the mapping coordinates are nothing but what? The types of relationships. Types of relationships. So what are those? One to one is one type of relationship. One to many. So one to many to one, and many to many relationship. So these are all having a certain level of instances that are going to perform the relationship in between two entities. Relational model. So the next model is what? Relational model. It can represent as a table with columns and rows. It can represent with a table with columns and rows. Each row is known as what? A tuple. So in this relational model, each row will be called as what? Tuple. Each row will be called as what? Tuple. Each table of the column has a name or attribute. Each table of the column has a name or attribute. So from this, what is meant by entity, types of entities, and what is meant by relationship, types of relationship will be discussed in this way. So entity is nothing but what? It is an object or class or person or place. How we can define in this diagram? An entity can be represented as rectangles. An entity can be represented as rectangles. So considered an organization as an example. So manager, product, employee, department, these are all can be taken as an entity. So consider example manager, product, employee, department, these are all can be taken as an entity. So employee is an entity, department is an entity. So here the employee works for department. So here works for is the relationship between two entities. And these there are different types of entities. Weak entity. So an entity that depends on another entity, an entity that depends on another entity is called as what? Weak entity. So that entity which is depending on others. The weak entity does not contain any key attribute its own. So if it is depending attribute that doesn't have any key attributes, So it is represented by a double rectangle. So it is represented as double rectangle. So here, in this example, the loan is an main entity and the installment is a weak entity because the installment is depending upon the loan entity. Installment is depending upon the loan entity. So installment is will be taken as weak entity and strong entity. So strong entity is nothing but what? The key which is having a primary key. That is called as what? Strong entity, and it does not depending on other entity also. It does not depending on other entity also, and it can be represented using single rectangle with thickness. So thick rectangle it is showing. The relationship between two strong entities can be represented using a single diamond. Using a single diamond. It can either have a total participation or no participation. You could either have a total participation or no participation. And second one, attribute. The attribute is used to describe the property of an entity. It is used to describe the property of an entity. So there is nothing but a property of an entity. So property of an entity. So attribute is nothing but what? A property of an entity. And here ellipse is used to represent an attribute. So for example, here a student, take an example, student as an entity. For this, all properties are what? For this, all the properties are ID, phone number, age, name. These are all what? Attributes. These are all attributes, and they are all properties of that student. They are all properties of that student. Key attribute. So the key attribute is used to represent the main characteristics of an entity. So key attribute is nothing but what? It is used to represent the main characteristics of an entity. So it represents a primary key. It represents a primary key. The key attribute is represented by an ellipse with the text underlined. So an ellipse with the text underlined. So here the ID is the key attribute. ID is the key attribute, and remaining these three are non-key attribute. Non-key attribute. The student is an entity here. Student is an entity. Next one, composite attribute. Composite attribute. An attribute that composite of many other attributes is known as what? Composite attribute. Is known as composite attribute. So an attribute that composed of many other attributes. So it contains many other attributes is called as what? Composite attribute. So it is represented by an ellipse, and those ellipses are connected with any other ellipse. So here name is an composite attribute. Name is a composite attribute because this attribute can have many other attributes like what? First name, middle name, and last name. So first name, middle name, and last name. These three are the other attributes. These three are the other attributes. So that is a composite attribute. Multi-valued attribute. An attribute can have more than one value, and these attributes are known as what? Multi-valued attributes. So here phone number is an attribute, but it can have more than one values for the user. It can have more than one values for the user. So it is represented as a multi-valued attribute. So the double vowel is used to represent multi-valued attribute. For example, a student can have more than one phone numbers. Next one, derived attribute. Derived attribute. An attribute that can be derived from other attribute is known as what? Derived attribute. So the other attribute can be derived from another attribute. It can be represented by a dashed ellipse. For example, a person age changes over time and can be derived from another attribute like date of birth. So here the age is the derived attribute, and it is in dashed ellipse, and this will be on basis of this birth date attribute. So based on this, only age can be changes. Age can be changes for every time of the user. Relationship. So what is meant by relationship? The relationship is used to describe the relation between two entities. So it is used to describe the relation between two entities or any entities. And diamond or rhombus symbol is used to represent the relationship. So here this will be the entity. So the relationship exists in between two entities. So here entity 1 and entity 2. Teacher is the entity 1 and student is the entity 2. In between them, teachers is the relationship name. Teachers is the relationship name. So types of relationships are what? One-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. So here one-to-one relationship. When only one instance of an entity is associated with the relationship, then it is known as what? One-to-one relationship. So one instance from the left side. So only one instance from the left side, and only one instance from the right side. Only one instance from the left side, and only one instance from the right side also. Then those two are associated with the relationship. Then it is called as what? One-to-one relationship. The second one, one-to-many relationship. So when only one instance of an entity on the left side and more than one instance of an entity on the right side. So more than one instance on the right side, only one instance on the left side will be associated with the relationship. Then it is called as what? One-to-many relationship. Similarly, many-to-one relationship. So from the left side, more than one instance from the left side, more than one instance from the left side, only one instance from the right side, Those two are associated with the relationship. Is called as what? Many-to-one relationship. And the last one, many to many relationship. So when more than one instance of an entity on the left side, and similarly more than one instance of the entity on right side, more than one instance of the entity left side, and more than one instance of the right side will be associated with a relationship is called as what? Many to many relationship is called as what? Many to many relationship. So this is the way we have to understand the relationship types are existed. Relationships types are existed. So once again we revise the topic which we discussed in this session. So here the first, what is meant by data. So what is meant by database, and how the data is different than the information. So database software, what is meant by data warehouse, data mining, information, and how the data is different than the information, how the data will be becomes an information when it is processed or structured, and what is the database software, DBMS, what is meant by DBMS, and what is the data abstraction, and what are the different types of architectural components are used to express the structure of database management system, and how what is the model to design the database, good database, what are the models, different models which we are used to design the database. In that, entity relationship model is one such type, so which contains entities relationships and different types of attributes, constraints, all the things. So here different types of relationships are there. So relational model, what is meant by relational model? It contains what? Table, columns and rows. Rows will be called as tuples, and entity, types of an entity, weak entity and strong entity, and attribute, types of an attributes are key attribute, composite attribute, multi-valued attribute and derived attributes. And relationship and types of relationships are nothing but one to one relationship, one to many relationship, many to one relationship, and many to many relationship. So this is all about the different types of definitions of a database architectural components, database design models, and the model which is popularly known as entity relationship model, which contains an entity and attributes and types of relationship. So that's all. That is all about definitions of database and relationship models. Thank you all.
Like, share, and subscribe. Hit the bell icon for more updates.